We got a guy named Tommy wants to put some money away, and he's going to put away $100 in an account that earns 2% interest. We want to know how much money will be in that account after 15 years if the interest is compounded annually. So the first problem is to figure out which of these three equations you might want to use. This might seem like the first obvious choice. However, I'd say in this case, because it's compounded annually, that would mean once per year. That would mean n equals 1, and you can definitely use this equation with a value of n equals 1. But if you think about it, if you take a value like r and divide it by 1, it'll be the same thing. If you take the value for t and multiply it by 1, it'll be the same thing. So we really could just use this formula since the value for n equals 1. If these sorts of formulas do stress you out, I would recommend you focusing on making a little list for yourself. Like I said before, if you're using that n equation to be n equals 1, anytime n equals 1, just don't do it. Just use this. And then t, we don't know. So this $100, is this what he wants to have in the future, or is this what he's starting with? This is what he's starting with. That makes it a principal. This 2% as a decimal is 0.02, and the time is 15 years. So the amount after that 15 years is what he started with. 1 plus 0.02 is going to be 1.02. Then to the 15th power. If I get a calculator out and I plug all that stuff in, I will find this crazy gross decimal. We are talking about money, so we can round to the nearest penny. Since that is a 6, that'll become a 9. After 15 years, he will have $134.59. How much more money would Tommy have after 15 years if the 2% were compounded daily? So this compounded daily is going to change some things, and I am going to want to have a value for n, and I am going to have to use this equation over here. So daily means how many times per year? Daily means 365 days in a year. Let's always assume that it's not a leap year. So everything else is the same. We don't know the future amount, but he's going to start with $100, and it'll be, this time I have to actually write things out. 100% of what he has plus that 2% broken into 365 tiny little pieces, and that'll happen over the course of the loan. Let me think about this. 365 times a year for 15 years is 5,475. It's a lot. This might seem like a pretty big power, but this number will basically be very close to 1, so it's not going to break our calculators. Plugging all that fun stuff in, I'll have 100, parentheses, 1 plus the 2% divided by the number of days. Please note my use of parentheses here, where I put them, where I did not put them, and that'll be raised to that 5,475 power. Oh, I bet it's a lot more money. Let's see. What? So if it's compounded daily, he's going to make, what would that say? 134.98. And now be careful though, because the question here wasn't how much will he have, but how much more money would be in the account. How much more money would be in the account. So with the annually he has this much, with the daily he has this much, and the difference there is the 134. You think I could do this in my head, but I'm going to take no chances right now. 134.98. Oh, well, I should have subtracted them in the other order, but the fact that it's negative just means I put them in the wrong order. He has a whopping 39 more cents. 39 more cents! He can now get the next size up on his Slurpee. Alright, good luck you guys. I hope that made sense.